Today's module, Training Module 5.2, is GPS product selection. So the purpose of GPS product selection is to help you decide among all the tooling systems within the Horn program. Just for grooving, you see that we have many systems to choose from, and hopefully at the end of this training you will have a better idea of where to apply certain systems and where to apply others. So if you look at the whole program, you have internal and external grooving. You have systems that are purely for external grooving or part off or profiling. So with the 209, the 223, the 217, the 216. So the first thing to kind of know is where those numbers come from. So 209 basically means that it has two indexes. So the 2 represents two indexes, and the 9 is roughly the length of the blank. So as you increase in the length of the blank, you also increase in Tmax. So you can see on some of the systems, so 295 Tmax, which is the depth of cut on a 16 versus on a 209, it's 196. So you can see that as you increase in number on the back end of the part number, you also increase in Tmax. That also limits your ability to go inside of smaller bores. So a 209, for instance, fits inside a 630 thousandths bore, where a 229, you need 1.496 inches to fit in the bore. So just a couple of things to get us started here on the GPS system and how the part numbers are organized. Graphically, the GPS system can be divided into internal and external, and purely external. So the internal systems are the 209, the 216, and the 119. So 119 means that it has one index. So by not having a secondary cutting edge, that allows you a deeper Tmax into the part while maintaining a smaller bore diameter. The internal and external, you have the 223, the 229, the 217, the 315, the 224, the 312, the 123. And then on the external groovers, you have 316, 64T, and S100. Delving deeper into the part number, when you see an S, that means it's precision centered. Doesn't necessarily mean that there's no grinding on it, but for the most part, this is a centered part. It's precision centered to have the accuracy. There may be some ground parts, maybe the flank of the insert is also ground, but typically you see the S designation when you have some kind of preformed geometry on the rake face. So the S just means precision centered. Then you have the series of tool. The series of 224 is going to have its compatible holders. A 229 is going to have its compatible holders. When you switch series, you can't switch holders. So a series pretty much locks you into a set of holders for that series of tool. The width, so the width being in millimeters in this case. There are a few inserts that are in inch, but you'll see a U designation on that for inch tooling. So width is in millimeters, so this would be a 3 millimeter insert width. Geometry, so that geometry can vary from a 3, a 5, an L, an A. Those are all given in this part of the nomenclature. Then you have a corner radius at the end. Use the numbering system as a guide, but don't necessarily, there are exceptions to the exception, so don't necessarily rely on that. Rely on the part dimensions given in the catalog to make your selection. Another key component of all the different systems is that there are insert sizes. So the size of an insert is given. There's a column on the catalog page for the size, and you need to match the holder size and the insert size. So progressively, as these get larger, you'll tend to find that you have bigger width of groove. So the size is in line with the locating surface and not the width of the insert. So sometimes it corresponds. Sometimes you have a size 5 insert and it's 5 millimeter wide, but it's more or less the locating surfaces and not the width of the groover. Another thing to point out, as I did earlier, was that the number of cutting edges is given at the front. So the number of indexes. So a 119 insert has one index. A 123 has one index. The S100 system has one index. So the value in these systems is you can use them for deeper part off and deeper grooving applications because you don't have the geometry on the back end to interfere. And then again, the approximate length in millimeters. So you can see a 119 is a shorter blank or insert than a 123. And then a 100 is bigger than the 119 and 123, which kind of diverges from that logic, but that's why I say it's approximate. Also, you have 2 cutting edge inserts. So this has 2 indexes. So each of these insert series have 2 indexes on them, and then an approximate length. So same situation. So you can see a 209 is much shorter than a 216. A 217 is just a little bit bigger than a 216. A 223 is a little bit shorter in blank size, depending on the pocket size. The 224 and the 229 being the largest size of groover. So when you know that you have a deeper groove, you're going to go for a 229 or a 224. If you need to get inside a bore, you know you're going to go with a 209 or a 216. So those are opposite ends of the spectrum. We also have 3 cutting edge inserts. So you have the 316, the 315, and the 312 system. So the 316 is a direct mount, 315 is a direct mount pocket, which just means there's a screw that goes through the insert into the holder. And then the 312 is a top clamp. So the hole can be kind of deceiving. The 312, the hole there is not for clamping purposes. It's more or less manufacturing purposes on horn's end. So 312 is a top clamp, 315 and 316 are direct mount pockets. You also have different seating sides, so different configuration, and that means those tools are not interchangeable with one another's holders. So keep that in mind when you're selecting a system. Best process really is, 316 and 315 are systems designed for really heavy side loads like you would find in threading, for instance. That's why you'll find a lot of threading product in the 315. Then the 316 is also direct mount pocket, but it has the capability to do narrower grooves, but with good rigid contact. And then the 312 has a lot of different type of insert. Is a very broad system with a lot of applications. You also have the 64T. So 64T means it has 6 indexes. And then you have the D max, so 4T is the max part diameter, where T max is 5.5 millimeters. So that's the maximum depth of cut for the 64T would be 5.5. That is dependent on the diameter. So as you can see, to clear the insert, you do need to pay attention to the diameter of the part in order to get the appropriate Tmax. All these values are given. You look at the insert page for 64T, you'll see that there are tables given the Tmax based on the diameter max of the material. Just to make sure we solidify some of these terms, because these are important, just so we're all speaking the same language. The minimum bore diameter is d min. The reach or distance from the front of the part to the farthest point is L2. The depth of groove is Tmax. So that's a short German is Tfall, which is depth of groove. Width of groove is W, and Dmax is the maximum workpiece diameter. So the Dmax is tied into the style of the holder. For instance, this holder that's shown, it doesn't really have a Dmax because you run out of depth of groove long before you would run out of Tmax, because the insert has a smaller Tmax window and the holder doesn't need support underneath the insert. You therefore don't have a Dmax value on certain types of holders. So how do you select a holder correctly? So the logical process to follow to find the right system. So first is it internal or external? So is it an internal groover or an external grooving application? So like the 209 and 216, those are the ones that are going to be targeted for the internal grooves. And then how many edges? What's the requirement for the edge economy? Are you looking at, you need 2 edges, you need 3 edges? So that's going to help you decide between using a 312 or using a 224. Then the application. So for instance, if you chose a 312, maybe it doesn't have the applications necessary for threading. So you would then switch over and look at the 315. The D min, so especially important on the internal grooving, you need to have the proper D min. Tmax, so different systems like the S100 has a huge Tmax when you're doing a part off application or a very deep groove. The L2, so do you have the holders available to reach into the part to get to where the groove is? And then Dmax is the least limiting because you have a lot of holder options. So the Dmax comes from the holders available and how much clearance you have underneath the insert. If you look at the different systems, if you look at internal, external, this is internal. So you would want to look at reach length, bore diameter, so the minimum bore, and then the depth of groove. So you can see from this chart roughly that a 209 system has very limited reach into the part, but the bore diameter can be very small, and the Tmax is pretty well in line with the rest of the systems. So you're not going to have trouble reaching the depth of groove that you need. You can also see though that the 224 system is a good choice when you need longer L2s into the part. Also, when you need a fairly small bore diameter and your Tmax needs to be fairly deep. So the range of Tmax for the 224 system is pretty broad. If I want the deepest reach into the part, I'm going to choose a 312 system. So a 312 system is very long reach into the part. My limitations are though that I'm not going to have a lot of Tmax, so not a lot of depth of cut. And then my bore diameter is going to have to be a little bit bigger for the 312 system. if you look at external grooving, so you can, with external grooving, the three main criteria are the Dmax, so the max diameter of the part, that's related to your holder, the Tmax or depth of groove, and the W width of groove. So those are the three sort of main components you want to start with on product selection. So you can see with the 217 system, you have a very short Tmax, but actually very large diameter for the Dmax, and your Tmax is a little bit smaller, and the width is in line with the rest of the other systems, aside from the 64T and the 123. Those are limited on width wise for options. So the 217 is a good all-around choice when you maybe have some larger parts that you need to external groove on, because you're not limited too much with you're not limited by the Dmax. The 223 is also an option, as well as the 312. So the way that those inserts are held in the pocket, they leave you plenty of room to not really worry so much about the diameter of the part. The 64T, so the 64T system and the 123 system, those have more constraints on how big of a diameter part that you can run with them. 315 has a nice Dmax. The 224 is kind of in the middle, and the 229 also has a nice Dmax, Tmax, and width. And then if you want the with the S100, has a decent Dmax, and also width-wise, a lot of width options and a lot of depth options. Here's a kind of a down and dirty explanation of why you need the clearance, why you need to worry about Dmax. And basically, the clearance on the holder is your issue. So as the diameter increases, you need to pay attention, because you can actually collide with the holder. I know some end users have modify their holder to clear, but that's not a great idea. The best is to get an appropriate tool that has the clearance for your diameter. So keep that in mind. It's not always thought of, but in external grooving, but it does matter what the diameter of your part is in relation, especially to your Tmax. All right, that's it for today's training. Please join us for our live trainings. Look for those invitations in your inbox, and also look back here to our YouTube page. Hit that subscribe button, and get notifications when we post a new video. Thanks, and have a great day.